Okay, so for homework, we were supposed to use Blockly, and we were writing last time, to go through and work for octal, correct? Right now, the one we wrote last time was binary to decimal. Now we need to write octal to decimal. Hopefully, most of you found this pretty easy. All you had to change was that, and now it's octal. So we're done. So the octal version of this now will be length.
You have to change bin to oct.
Oh, thank you. It doesn't give me that option there. So, oh, it does. I thought I was naming it octal, or oct rather. So there's 85. So we're good to go. Okay. Now, what I'm going to do, just for clarity's sake, for kind of where we're going next, is I'm going to convert this back to what we had before, not caring if it works in Python or not. So we're going to kind of focus on making sure things work within the browser in JavaScript, just because I think that makes a little bit more sense. We don't have to use this this temp thing anymore. The temp was kind of our hack to make it work in both Python and JavaScript. So I'm going to get rid of temp here. We're going to start off at the length of our value, go to 1, counting by -1 each time. And what am I going to do each time through? I'm going to get the current letter and I'm going to ask a question, right? So I'm going to just move this out here real quick. And I'll go ahead and put in some logic. So we're going to ask a question. The question we're going to ask is if this guy is equal to 1, correct? Okay, and we're going to see how this breaks down a little bit in our example with octal. So I'm going to say if this guy is equal to the string 1, only then will I add place to my total. Okay, I'm going to change this guy just to kind of roll us back to where we were talking about last class. Change this back to binary to decimal. And just for the sake of argument, let's take this back to bin. Switch this back to bin. Okay. So now we're back to binary to decimal here. Yep, let's switch the 8 back to a 2. Okay. So now, every single time through our loop, we're asking the question, if the current guy we're looking at is a 1, then do what? Well, then take our total and add place to it. But only if we're looking at a 1. Okay? Why are we adding place? Because 1 times place is place. That make sense? Okay, so this is back to our kind of our original rep row. Let's see, set total equal to that, set place equal to that. Oh, yeah, we're returning total. Oh, I need to take in an actual binary number, don't I? There we go. There's 15. 1s, 2s, 4s, 8, 16s. It should not be 15. If min at letter I is equal to a 1, set total equal to total plus place. Place becomes 1 greater than it used to be. So this should be 1s, 2s, 4s, 8s, 16s, 32s. So this should be 36, 38, 39. This should be 39. Place is 1, total is 0. Start with the length of bin, go down to 1, count by -1. If bin at I is equivalent to a 1, set total equal to whatever it currently is plus place. Set place equal to place times 2. So, right?
Is it because you're not multiplying place outside of the loop, so when you're coming across 0?
Oh, it is. Thank you. Thank you. We always want to update place. See, I was trying to trick you. You got it. All right, yeah. So regardless of whether we add something to our total, place always needs to go up. Now we should be back in business. There's our 39. Okay. So in any case, this is the version of binary to decimal that I want to start with today as we talk about an alternative solution to octal, which then is our gateway drug into converting between any base and decimal. Okay? So if I want to take this code and I want to convert this to the octal version, and we're going to do this the crappy way first. Okay? If it's a 1, then what am I going to do? Well, I'm going to add place to it. Otherwise, else if, oh, it's just strange. Does that work? Is that what I'm going for? No. I need to do it up here. There we go. If it's a 1, add place. If it's a 2, then I'm going to add 2 times place. Oh, it's binary. I need to do math. Oh, don't get too close to the garbage can. Gobble you up. All right. Place times 2. Okay. Actually, can I do another else if onto this? Yeah, I can. Else if it's 3, place times 3. Else if it's 4, place times 4. Else if it's 5, so on and so forth. Okay. Starts sucking pretty quick. All right. So one thing we can do, and I think we saw this last time, that we can do in JavaScript, and that's why we're going to care mostly about JavaScript right now instead of it working in Python as well, is we can actually say total is equal to our letter and this is kind of what we had I need to put, that's why we had the variable. Actually, let's go this route. Well, I guess before I go any farther in this direction, I can keep adding else ifs to this for the 1, the 2, the 3, the 4, the 5, the 6, the 7, and the 8. If we don't care about Python, we only care about this working in JavaScript. Basically, we only care if this guy works when we hit the red play button. Is there anything I can do from a math perspective to keep our question here. If it's a 1, do this. If it's a 2, do this. If it's a 3, do this. We see how this is very verbose, right? And what if I said, let's go to base 16, or base 30, or base 36, so on and so forth. We just have a giant if statement. We don't want to have that, right? Can I multiply by that place? How can I avoid, let me write back the way we had it before. How can I avoid creating a variable called temp? Or a variable called anything. And we'll start temp off as just the empty string in this example. How could I avoid taking temp setting it equal to the current character and then setting total equal to total plus or total is equal to total plus place times temp. We saw that the math works this way last time, so I'm going to take, we no longer need to ask that question at all. So we can take that out. I need to set total equal to that. Okay, so set total equal to total plus place times temp, and then always increment place. So this happens in the event that even if temp was a 0, it'll take place times 0, which is 0. And this will work in JavaScript, not in Python. Python, this gives us some issues, but this will work in JavaScript. And we just needed the to put it inside of temp, mostly because of Blockly. It wouldn't allow us to take a string and multiply it by this directly. It required us to put it in a variable first. All right, so now, start off, this is the empty string.
Oh, you said you set temp to the letter.
Oh, I never set temp. Well, actually, I did set temp, and then I deleted that entire block. So we'll set temp equal to our text, and here is, the text name is bin, and we want letter at bucket I. This guy, right? Okay, there's our 39. Okay, so we're back to a functioning thing, which is pretty much what we had before. Actually, I think it's identical to what we had before. And this now works for base 8. Let me... Okay, but what we wanted to see there is if we wanted to write the base 8 version the old way we were doing, we were asking, is it 1? Going from that binary version to the base 8 version required a whole bunch of if statements, right? What if I want to convert it to base 10? Well, I'd multiply by 10 each time, right? I'll just leave all the words correct the same way right now. So it'll still go through everything. It'll still multiply everything by place that we hit. Multiply place by 10 each time. So now we'll convert this decimal number. So, I mean, that's a decimal number, just a big decimal number. So let's do 1458. Okay, so 1458, we're going to convert that from decimal to decimal. Doesn't make a whole lot of sense to do that, but it should functionally work, right? Okay, because all the conversions work the same way. So there's 1458 came out of there. We're able to convert decimal to decimal. What if I want to make this work for base 16? Hexadecimal numbers. Well, we assume we have to come down here and multiply that by 16 for the different base. And then I'm going to convert this. And let's see. Is it 2056? Is that my favorite one? It's not. Well, I'll have to stumble upon one that's, here I can just do this real quick. My favorite hexadecimal number is BAD. So let's do calculator. So I just need to get the so let's go to base 16, BAD. If I go back to base 10, 2989. That's what I want. 2989. 2989. Now I run this and we get 10. We get bad values because we're not doing the conversion. Okay? So really, actually, that's not what I expected it to be. BA, this should be oh. We're going from the base. So I should be able to pass in BAD like this and have it convert it to 2989. Okay? Because this is a legal hexadecimal number. Well, right off the bat, we're going to get some errors here. Because we're going to try to take place and multiply it by B. It's going to go south real quick, right? So, not a number. Can't take a 1 and multiply it by B. You can't take a 16 and multiply it by A, so on and so forth, right? So we need to map between the digits and the characters. So if we go back in here, and we look at hexadecimal, so this is base 16, we can say that 0 through 9 already exists, but 10 through 15, so the legal digits in base 16 are 0 through 15. Just like the legal digits in base 2 are 0 through 1, legal digits in base 10 are 0 through 9, the legal digits in base 16 are 0 through 15. 10 through 15 are represented as A through F in hexadecimal, okay? Where A is 10, B is 11, C is 12, so on and so forth. Okay, so we need to map between those. So if I'm converting BAD from hexadecimal to decimal, what I need to do is I need to convert the B into an 11 before I multiply it by place. Okay, just to show this here. Here's BAD. This is the 1's place. This is the 16's place. This is the 256's place. All right, so we're going to have D times 1, and D is the 10, 11, 12, 13's place. Okay, so this is D, or 13 times 1. A is going to be A times, or A, or 10 times 16. And then B, or 11 times 256. So we'll have 13 times 1 plus 10 times 16 plus 11 times 256. And there's our 2989. That makes sense? So we need to have a mapping between all of our characters, and the equivalent number. We need to do this the Blockley way. Okay? I could certainly write a zillion if statements like we were just looking at. Wouldn't be fun, but it would be possible. Okay? Else if, and scrolling gets a little funny in Blockley, so things start going south pretty quickly. So we need to look at some additional constructs that we have in here. All right. First of all, we have a couple different things we can use. I'm going to go into text. Let's see. That gets me a letter. I want to know what this guy gets me. So let's look at that. We're not actually going to call our function anymore. We'll just leave it up there as an untapped resource. So I'm going to set answer equal to, I actually need to, we'll just call this S. And then I need to create my set S equal to something here. So we're going to set S equal to hello. And then we're going to print in S the first occurrence of L. I'm hoping this gives us a number, not the L. But we'll see what it actually gives us. We don't need this anymore. So as it stands right now, I have this big function up here that I never use. So this is just a wasted function, but I don't want to delete it. Okay, so binary to decimal is just sitting up there. But here's my actual program. I'm just setting a variable name S equal to hello, and I'm going to print out this text function that looks in S and finds the first occurrence of a certain character. Okay, we want to see what does that give us. I'm hoping that gives us 1, 2, 3. 3 it does. Good. Very helpful. Okay. Given that, how could I modify my code up here? So now we just looked at that one trick. How could I modify my code up here to now work for base 16? Such that when I'm multiplying B times place, it actually multiplies 11 times place. When I'm multiplying A times place, it multiplies 10 times place, so on and so forth. How can I use this little trick here to do that?
Using the total expression.
Well, here, let's go this route. Forget about this guy up here for right now. If I'm down here and I want this, when I look for a A, I want this to boil down to 10. When I look for a B, I want this to boil down to 11. When I look for an F, I want this to boil down to 15. When I look for a 4, I want this to boil down to a 4. I just want that to work. What can I do here? Go ahead.
was gonna say create a list with A through F.
Uh,
and set-
certainly possible to do lists, but we're not doing lists yet.
Okay.
Doing it with strings. So using this trick I've shown here. It's gonna be the same, almost the same logic you're about to use. Just do it in terms of strings. So go ahead and explain what you wanted to explain.
I was gonna say use a list and then set it to A through F, and then use in list set something as whatever,
Why just A through F?
because that's the values for 10 through 15, isn't it?
Okay, well, what about the values for 0 through 9? I want a 4 to boil down to a 4. So if I say, that, and I print out first occurrence of 4, it's going to give me a 4. That make sense? 1, 2, 3, 4, 5, 6. If I say give me the first occurrence of A, it's going to give me a 10. Because I put A at position 10. Go ahead.
You can do 1 through 9 and then 8 through F.
Okay, what about 0? 0 going to hurt anything? Seemingly not. We were multiplying by 0 up here, right? Okay, but her concern here is right now 0 is at position 1. Kind of breaks everything by 1, correct? So we could subtract 1 from whatever comes out of there if we want to support 0. But do we ever actually have to support 0? Anything times 0 is going to be 0. Okay, so we only need to store the 1 through 9 as you suggested. 0 could work. We would just have to subtract 1 from whatever came back. Okay, so now if I say here's a string that happens to have all the legal digits in it from my from what I'm looking at, my mapping. If I look for an A, it's going to give me a 10. If I look for a 5, it's going to give me a 5. Why? Because the character 5 lives at position 1, 2, 3, 4, 5 in there. That's where it found it. 6, 7, 8, 9. A lives at 10. B lives at 11. C is at 12. So on and so forth. Okay, so we built a string that's in the right order. Okay, a lot of times I'll call this guy, I'm going to rename it. I'll call this guy map. Okay, and I'll go ahead and I'll put map up here. Oh, it came with it, I see it. Whoa, very, very dangerous stuff. And that's some serious glue, isn't it? Okay. So I have map up here, but when I do my math, I'm not just saying temp. I'm going to look for temp inside my string. I'm going to look for the first occurrence of it. And I'm going to multiply place by map. So if I'm looking for a 1, this guy will get me the number 1. If I'm looking for a 2, this guy will get me the number 2. So on and so forth. Make sense? So now if I pass in, if I need to call my function again. It's still called binary to decimal, but that's okay for a second. And we're going to pass in BAD. And then I want to print that. Ooh. So I'll print out the result that comes out of passing in BAD. I get my, 2719. That's not correct. Hold on. This is the 1s, 2s, 4s. Let me do something here. Oh, too close to the garbage can. Oh, I'm doing the wrong guy here. I need to find the first occurrence. That's what I want. In text BAD. Find the first occurrence of, let's do B. And we're going to print that guy. So this should, actually, I need to do it in this guy. So we want this to give us a 10. Oh, it gives us an 11. That's actually interesting. So the search string searches based on a base of 0. So what I really need to do is I need to make this now. Wait a minute. Wait. No, that's the wrong direction. The first occurrence in this text.
Wouldn't you want it to give you 11 because B is equal to 11?
Oh, it is. Why am I thinking 10? I haven't had enough coffee today, obviously. Okay, so it gives me the 11. That gave me what I wanted it to give me. Okay, we're good. A should give me 10. Oh my gosh. It's like Pac-Man down there. So A should give me a 10, which it will. And D should give me a 13. Which it will. Okay. Which means that up here, I have my mapping string. I go through all the characters, and each time through, I'm saying multiply place, well, set total equal to total plus place times, here's my string map, find the first occurrence of temp, and temp is the current letter. I'm multiplying by 16. That should place is 1, total is 0, temp is nothing to begin with, map is A, B, C, D, E, F. That's correct. Count through all the characters. Set temp equal to the current character. Set total equal to that. Set place equal to that. Okay, well, that looks all fine. Which means now I should be able to call binary to decimal, passing it the text BAD, and then print that. Oh, I still have a print statement somewhere up there, but it's still giving me the wrong answer. Wonder if Where's that other print? Uh-oh, we just lost everything. Perfect. We're okay. Everybody relax. I need to go in here. We really need to have a version of this page that saves. Wouldn't that be handy? Okay. So we need to multiply this by 16. We need to set our variable map. Equal to all the characters in the alphabet. Okay, and then when we do our math here, we're going to say place times in map first occurrence of temp.
Reading it the wrong way, isn't it?
Like that's why it's giving us the answer, the wrong answer.
Possibly.
Well, it's looking for the first occurrence, and that's what we were testing against. Let's see what it gives us now, and then we'll check the code that it created. All right, so we are multiplying temp by this guy. So octodecimal, set place, set total, set temp, set map. Go through all the characters in it. Each time through, we're going to set temp equal to the current character. Then we'll set total equal to total plus temp times. No. Total plus. This isn't right.
You had it before total plus place times temp, text and map, find first occurrence of text temp.
Yep, that's what I have. So total equals total plus. We're going to look in, well, total plus whatever the current place is times the first occurrence of temp and map. It should be the right math. And then we'll multiply place by 16 each time through. Ultimately return our total, storing our answer. So I'm actually passing in BAD. Then we're printing out our answer. Not read property length. Oh, it's called octal, right?
Yep.
2719. Okay, that's the same answer we were getting before. Let's look at the JavaScript and see what we're getting here. See, JavaScript is a language that starts with base 0. We talked about that last time. So having said that, let me actually just try something here real quick. Doesn't make sense that it should work this way. That's actually even worse. We're closer, but still not right. All right, so let's operate off that then. Place is 1, total is 0, temp starts off as nothing. Here's map. We're going to start at the end, octal.length. I'll go all the way to 1. Start I off at start, which is the length of octal. Keep going as long as it's greater than or equal to 0. Really, I think that should be 1. Well, let's see. And then we'll add our increment to it, which is going to be -1 each time. So temp is going to be equal to octal.char at I minus 1, which is correct. So if we have BAD that has a length of 3, the last legal bucket in JavaScript is 2. So the first time through temp will be equal to 2. Then we're taking the, well, temp will be equal to whatever's at bucket 2, which in our case here will be D. We'll find map.index of D, which should be 13. I think it will be. In fact, let's, while we're in here, let's just print out temp each time through. We should see a 13, a 10, and a, oh, okay, we've got D, we got A, we got B, we have those. So now let's print out this each time through. Let's just print out the mapping. So this should be 13, 10, 11. There's 13, there's 10, there's 11. Okay, that's all happening right. So the problem has to be order of operation here. I bet you we just need another variable. It's got to be that we're adding place before multiplying. That's all I can think of. So if we create another variable in here, actually we've already used temp this time through. We've gotten that letter. So I should then be able to just double use temp. So we'll set temp equal to that, and then we'll add that to total. No, it wasn't the problem. Let's go back here. This is troubling. Okay. That gets us our character. We're currently printing out the map and index, so that gives us the 13, the 10, the 11. We've seen that. Then we're saying total is equal to total plus place times map at index. Okay, that should be fine. And what we're adding here, that's the problem right there. Total is equal to total plus place times map at index of temp plus 1. It's taking this times this before it adds the 1. Well, really, we need this guy right here. We need that stored someplace, not the whole math. So here, I'll show you here. So we're going to go ahead and set temp we'll go here. So we have temp there. Now we're going to set temp equal to that guy. Temp, okay. And then we're going to print out temp. Then each time through, we're going to take total plus place times temp. I know we kind of had this a second ago, but let's see what temp is each time through here. So we start temp off at a character. Then we immediately replace the value of temp with that character while mapped in map. And then we'll print out temp. So temp each time through should be 13, then 10, then 11. And that's the value we have right here then. So place times that should work out for us. There's the 13, there's the 10, there's the 11, and there's the 2989. All right, so the problem we had before, and I can actually see it in the JavaScript now. Notice down here, we're setting temp equal to map.index of temp plus 1. That way, when we come down here, we're saying place times temp. Before this said place times map.index of temp plus 1. And what it was doing is it was taking place times this part of it, not including the plus 1, because multiplication comes before addition. Yeah, actually, interesting problem. So sometimes we do have to go and look at the code to see why something's working the way it's working. In any case, now that we have that functioning, this guy will work for any base 16 number. And we can even take this further and change this to make it work for a up to base 36 number by just finishing out the alphabet. Right? Now it'll work for converting any base. Make sense? Okay, so what we're going to do next time is, I meant to do it today, but we didn't, is kind of what you were talking about. We're going to start looking at lists and how we can use lists for different things. Lists are actually going to connect to a programming concept called arrays. Okay, so we'll talk about arrays next time, and then see how lists connect to that. Sound good? All right, I'll see everybody on Wednesday. I'll just make the announcement here. If you are doing the hackathon with us, which is a couple of you, I sent an email this morning. Make sure you see your email you got from BattleHack to go confirm your ticket. You got to hit the button that just says, yes, I'm still coming.